Hello everyone, welcome back to the another session in series of learning design and analysis of algorithms. This video is to explain about asymptotic notations. So the main objective of this notations is to measure the performance analysis. So in the last previous videos we were discussed about performance analysis will be calculated respective to time and space complexity, right? So the definition of asymptotic notations is time and space complexity or performance analysis of an algorithm is measured by notation which is called as asymptotic notation. So the main objective of this notation is to measure the time and space complexity, and these notations are, there are six notations what do we have, but all six we are not going to use. So preferably we'll take three into consideration. That three are big O notation, omega notation and theta notation. Let's see each one. Big O notation. So before we'll discuss about these three, let me talk with an example. So let us assume that I have some algorithm through which I'm going to add two numbers. So for this what I'll do is, so I am taking one function. Now I'll put c is equal to a plus b, and here it is c semicolon, it is not semicolon. And next we will be printing the statement of, the value of c. So this print c in the sense that will take percentile d c only, but only to understand I'm explaining this. Okay, now let's see this. Now assume this is what f of n, this is what my algorithm. Okay, now g of n is what the mean of growth rate. That growth rate of the function will be depends upon the number of comparisons what we are taking to execute this code. So as this program is written using of sequential statements, that means there is no selection statement, there is no condition which can be repeated. So every line will get executed, right? If my f of n SLOC is, now the lines of code is what, 1, 2, 3, 4, 5, 6. So there are 6 lines of code, all 6 lines will get executed. So the time complexity of this is what, constant time, which is 6. The and if you take the g of n is what, the growth rate function. G of n is what, it is exactly equivalent to f of n. So all lines will get executed. Now there will be another possibility that if I wanted to add two numbers based upon some condition, if a greater than b, then only I will add the numbers. If a is not greater b, then I will take one more block which is else block. So in that case, when a is greater b, then only this statement will get executed. If it is not, else block will get executed. Okay. Now f of n still it is 6 lines of code. We were added 2 more lines, so it will be of 8 lines of code. But all 8 lines will not execute. Now my g of n will not take all 8 lines into consideration, because I have used this decision making statement, this condition statement. So either this block will get executed or this block will get executed. That means g of n will take only 4 lines of code. If you have 8 lines of code, definitely g of n will be less of f of n. Am I right? And if you take a loop means what? The statement, the body of the loop has to be repeated for number of times. Now that means g of n will be definitely greater of your f of n. Though you have 6 lines of code, if I am using any loop in this picture, this line will get repeated for many times. So your g of n will be greater than f of n. Right. Now keep this in mind. Now let's talk about big O notation. Now in the big O notation, f of n value is low. In big O notation, f of n value is lesser than g of n. Okay, that means what? That is the maximum number of comparisons. C is more, means constant, n means your input. So f of n is lesser equal to c into g of n. That means the upper bound of your algorithm that will take the maximum number of comparisons. Okay, so that is what the big O notation. When big O notation will be represented when your algorithm is going for upper bound. So that is the last phase where you cannot see any comparisons. So in that case we will take big O notation. Okay. Now let's see the pictorial representation. These are my n values and this is the time complexity. So for each n time I have to take some, for each n value I have to take some time to execute the value. So now f of n will be lesser than the g of n. Fine, it is what upper bound. Now omega notation. Omega notation is again considered two functions f of n and g of n, and my n is input, c is constant. Now in this case, in omega notation, will f of n will be greater than, that means some selection statement may be there or some decision making statements may be there, or else your program will take only some little number of comparisons. So in that way we will take omega notation. So the equation or the relation of the both the functions are f of n is greater than g of n. This c denotes constant. Okay, so we'll use the notation which is omega. Now graphic pictorial representation is, or picture representation, c into g of n will be lower bound than f of n. So now the third notation is theta notation. It is this relation, that is uh, it will be accept the both cases, both upper bound and lower bound. So this is the pictorial representation. So the very most important concept in the subject of design and analysis of algorithm. So it is too simple to understand. So this is about asymptotic notation. Thank you all.